Hello again. This is Math 1220 coming to you from the College of DuPage, and the title of this lecture deals with matrices is how you do the plural, and other technologies for larger problems. And this is the first in at least a sequence of 2 lectures. I may break it into more. As always, please be an active learner as you watch this video. By way of introduction, let's think about a situation that we've done before. So to solve 5x equal 10, what you could say is I will multiply or I will divide both sides by 5, do the same thing to both sides, and I will find out that x is 2. Now that's the same thing as multiplying on both sides by the multiplicative inverse of 5, that is 5 to the minus 1 is 1 over 5. So if I take 1 over 5 times 5, I get 1x, and if I take 1 over 5 times 10, I will get 2. So x is equal to 2. Now it really is a very similar way we're going to solve larger problems using systems of linear equations, and we'll use matrices and Excel technology. But there are some important details and considerations, so please follow along carefully. So here are some definitions. Consider this system of linear equations: 2x minus 3y equal 4 and x plus 5y equal 2. Now, your system of equations has to be in this form. That means you have to have all your variables on the left-hand side of the equal sign. They must be in the same order. This column is the x's, this column is the y's, the next column would be the z's, and so on and so forth. And you must have your constants, 4 and 2 in this case, on the right-hand side of the equal sign. So then we can define, if we have it in this form, then what we can do is we can identify what is going to be called the coefficient matrix, which is going to be the numbers. Don't worry about the variables because we know what the variables are. So this is, the first row is 2 minus 3, 2 minus 3. This is a 1. It's a 1. You don't have to write it, but it is a 1 and 5. 1 and 5. Again, this is the coefficient matrix. This is the variable matrix. This is a 2 by 2, 2 rows and 2 columns. This is a 2 by 1 matrix, 2 rows but 1 column. And this is the variables in the order in which they appear up here, left to right. So this is x and y in this case. And then the right-hand side is b. Again, b is 4, 2, so that is going to be a 2 rows and 1 column, so this is 4, 2. So this must be in this form, and this must be in this form. And here we talk about that the matrix A was called the coefficient matrix, X is the matrix of variables, and B is called the matrix of constants. But you see, so this matrix equation AX equal B, which we've really set up, can be solved if A inverse exists. Now let's assume A inverse exists for a while, and you see if I take A inverse times A, I will get the identity matrix, and the identity matrix times x is equal to x. This is just like 5 to the minus 1 times 5 is going to be equal to 1, and this is 1x is equal to x, and then on the other side we found x was equal to 2. Also, matrix multiplication is associative. So anyway, we start with the equation AX equal B, and we multiply on the left by A inverse. And by the way, it is important, you must multiply on the left by the inverse because matrix multiplication is not commutative. But if we do that and we reassociate, we get x is equal to A inverse B. Now we're going to summarize this in the box. So suppose that a system of equations with the same number of equations as variables, that means it's a square matrix, can be written in the form AX equal B, where A is the square matrix of coefficients, X is the column matrix of variables, and B is the column matrix of constants. If A has an inverse, and sometimes it doesn't, but if it does, then the unique solution of the system is X equal A inverse B. This is how we're going to be solving problems today. So you might say, well, how do I find the inverse? Well, the best way is to use Excel. So if you go into Excel and you label Excel so you know what you're talking about, so this is going to be the matrix A, I just enter the matrix A in here. And then I go to a place that I designate to put A inverse, and then I use the function. And the function that I use in Excel is M inverse, that is matrix inverse. And then this is matrix inverse of something, so I have to put the what A is in there, and then I hit enter, and I will get the answer. And so we'll do this with an example in a bit. Also, we're going to be multiplying matrices, and the function that we're going to use there is matrix multiplication function. And again, we'll show you with an example how we do that. But that's how we take A inverse times B. But an example is worth 1,000 words. So let's consider the system of equations x plus y plus z equal 2, 2x plus 3y equal 5, and x plus 2y plus z equal minus 1. Now we're going to write this as a matrix equation. So look, what I have it in the right form. All the variables on this side, the x's are over the x's, the y's are over the y's, and the z's are over the z's. And my numbers are on the right-hand side. So this is the coefficient matrix. It is 1, 1, 1, 1, 1, 1. It is 2, 3, 0 because I see no z. 2, 3, 0. And then it is 1, 2, 1, 1, 2, 1. Now here I have x, y, and z, so x, y, and z is a column matrix. And B is 2, 5, minus 1. So the matrix equation is AX equal B, looking like this. Now we need to find A inverse. Now A is this, so that's what we're going to find the inverse of. So we're going to pause this discussion and use Excel to find A inverse. So I enter A here. This A I just typed so I know that this is A. And then I write my matrix 1, 1, 1, 2, 3, 0, 1, 2, 1. And then I type A inverse here just to make myself know what it is. But then I go to this column and I type equal because I'm using a formula, matrix inverse, and then I scroll across these using those as the input into the matrix. And then I close my input matrix, so then I close my parentheses and I am good, and I hit return, and this is what I get. So this was what I had as A. This is where I chose to put A inverse, and it listed A inverse as a 3 by 3. So A inverse is, it's decimals here, but it could be 3 over 2, 1/2, or minus 3 over 2, minus 1, 0, 1, and this is 1/2, minus 1/2, and 1/2, or as decimals as you see it here. Well, and you see that this is what I got as A inverse. In fact, they didn't use fractions, so this is exactly what I wrote. So this gives me A inverse. So my next step is I'm going to multiply A inverse times B to get the answer. Now the order matters, so it has to be A inverse times B in that order because matrix multiplication is not commutative. Let's look at doing that. So I have A inverse up here, and I have B down here. So what I'm going to do in this time is I'm going to go up to the very top of Excel, way up here, and I am going to click on the F sub x button, which writes the equal sign and allows me to pick a function. So I'm scrolling through here in this dialog box, and I'm going to pick out the function MULT, that's matrix multiplication. and I have two arrays. This is the first array, that's the second array. So what I do is I put A inverse, which is M2 through 04, that's this stuff up here, as my first thing, and then my second one is H2 through looks like 8, which is this one. And then I can hit OK, but I can see that what I'm going to get is an answer. I will get an answer here, and my answer in this case is 7 minus 3 and 2 minus 2. And you see that's what they got here. So the solution to the original system is 7 minus 3 and 2. Trust me, this is much easier than doing a 3 by 3 or higher system by hand. Now, we don't do these just to have interesting math problems, though. We do them to solve problems, and this is a discussion of a very useful example called input-output analysis. This was developed by a Nobel Prize winner, Leontief, and he was studying economics and input-output analysis. Okay. So here we go. Input-output models are concerned with the production and flow of goods and services. A typical economy is composed of a number of different sectors, such as manufacturing, energy, transportation, agriculture, etc. Each section requires input from other sections. And you think about that, you might say, well, I run a bank. Well, you still need to eat, so you need something from agriculture, for example. And agriculture needs to borrow money from the bank, and so forth. So we have this input-output matrix, and sometimes this is called the technology matrix. Okay. And the inputs required by the various sectors from each other to produce outputs is described in this matrix. This is the input-output matrix. Okay, so let's do an example then. Suppose a simplified economy involves just three sectors: agriculture, manufacturing, and transportation, all in appropriate units, usually money. 1 unit of agriculture requires a half unit of manufacturing, 1/4 unit of transportation, and 1 transportation. So this is how we put it in the matrix. So I'm going to go ahead, but the production of 1 unit of manufacturing requires a 1/4 unit of agriculture, and all of these things. So we're going to write the input-output matrix, and let's just remember that 1 unit of agriculture requires a half unit of manufacturing and a 1/4 unit of transportation. Okay, so you see 1 unit of agriculture, so these are the inputs here, the outputs are up here. So an input to get, these are the inputs. So to make a unit output of agriculture, I need 1/4 from manufacturing and 1/3 from that. So this is the input, and these are the outputs. Now this is a little bit unrealistic because you see this has, because I have zeros along the middle, that means you don't get anything from itself. That is unrealistic because farmers have to eat their food, for example. But we often will have these, and we will use these to solve the problem that Leontief solved. Okay, so here's an example then. Consider an economy whose input-output matrix was found in the previous problem. So that is the matrix that we're going to use, okay? And we're going to list the sectors in the same order, and we want to have output. This is my production matrix. So what we're going to do is we're going to be taking the 3 by 3 times the 3 by 1. And that tells us how much from each sector is used up in the production process. Okay, so here I take A times X, and I get this. So AX is equal to 29, 42, and 28. That means that we use up these units of, we need 29 units of agriculture that is internally consumed to make the other outputs. 42 units of the second one is required, and 28 of the third. But now what we can do is we can say, well, if we take the matrix D and we subtract off what's internally consumed, this tells us what do we have for export. And so D is equal to X minus AX. So this was X, and this was, as you can see, AX, and so I have this. This is called the demand matrix. This is what you're hoping to have that you can export externally, not being internally consumed. So that's what we're going to be solving here. And here what we have is that if we have a production of 60, 52, and 48, that satisfies an outside demand of 31, 10, and 20. Okay, now let's look at this just a little more carefully though. So we started with the equation, matrix equation D equal X minus A times X, but we can factor the X out of there. Now we factor the X out on this side because it's not commutative. So D is equal to the identity matrix minus I times X. But this is really of the form something times X is equal to D. So if the matrix I minus A has an inverse, then X is equal to the inverse of that. Again, I'm multiplying on the left times D. Okay, so let's look at another example then. Suppose in the example of 3 and 4, there's a demand for 516 units of agriculture, 258 of manufacturing, and 129 of transportation. That's what D is. What should the production be for each sector? And you might want to try this and then look, but that is totally up to you. So here's the demand matrix, and I minus A, this is I, it has a 1 down the diagonals and a 0 everywhere else, minus, this is what we had for A, so we get this is our matrix, I minus A. So we can use Excel to find the inverse of that, and if we do that, this is what we find is the inverse. We're rounding these off, and then X is equal to I minus A inverse times D, and we get this answer. I will ask you a problem like this on your final assessment, so this is not just rattling on, something you do want to know how to do. Here's another example. So economy depends on just two products here, wheat and oil. Okay, so to produce a metric ton of wheat requires a quarter metric ton of wheat and 33 metric tons of oil, and the production of 1 metric ton of oil consumes 0.08 metric tons of wheat and 0.11 metric tons of oil. Find the production that will satisfy demand of D equal 500 metric tons of wheat and 1,000 metric tons of oil. Okay, well, my transition matrix based on this is A is equal to, this is the input and output, so I get 0.25, 0.08, 0.33, 0.11. So I minus A, that is the matrix with 1s down the diagonal and 0, and I can subtract these, is going to be this. Now we use technology to find I minus A inverse. So I'm taking the inverse of this, and this is what D was. So X is equal to I minus A inverse times D. I multiply it, and this is what I get. And we've rounded this up to the nearest whole numbers. Now, in the VCM today, what we're going to do is we're going to practice solving systems of equations like this. We're also going to talk about setting up and solving word problems like this one. And we'll talk about solving input-output problems like perhaps number 32. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. We're all in this together. May God bless you all.